The Wugu Industrial Park is located in the southeastern part of Wugu District, New Taipei City. To the east, it is adjacent to the left bank levee of the Ekong floodway. It is bordered to the north by a highway, and to the south, it abuts the urban planning boundary of Xinzhuang. To the west, it connects to the right bank of the Zhonggang Drain. Due to the construction of the Airport MRT, the Wugu Industrial Park has been renamed as the New Taipei Industrial Park, and the New Taipei Industrial Park Station is an important station on the Airport MRT line. The New Taipei city government chose to develop a new industrial area in the low-lying land on the south side of the highway in Wugu and Xinzhuang. He used earth-moving and filling techniques to create a brand new industrial park. This area was designated to accommodate factories that needed to be relocated for the initial implementation of flood control projects in the Taipei area, including the construction of levees and the Ekong floodway. Additionally, it helped address the urgent demand for industrial land in New Taipei City. The Wugu Industrial Park's location is strategic and offers convenient transportation access. The total amount of fill used for this project was approximately 6.66 million cubic meters. The development of the industrial park was commissioned by the New Taipei city government and entrusted to the China Engineering Consultants Incorporated in May 1982 for project planning, design, and supervision. Due to the low-lying terrain in most of the planned area of the Wugu Industrial Park, with an average elevation of about 1 meter below sea level, and in order to balance development costs and provide moderate flood protection, the targeted fill elevation for the Wugu Industrial Park was set at 3.5 meters above sea level. The development project of the Wugu Industrial Park was a project under the administration of the Executive Yuan. Therefore, Mr. Lin Fengcheng, who was the county magistrate of Taipei County at the time, paid great attention to this project and visited the site multiple times. There was a total of 7 potential sources of fill material for the Wugu Industrial Park within the Wugu and Taishan areas. However, considering factors such as the quality of the soil, quantity available for excavation, and soil conservation, the evaluation determined that Baro Area No. 6, which is the hillside north of the Maosheng second village in the Wugu area, was the most suitable. To prevent soil erosion and the transportation of sediment by rainwater during construction, which could pose risks to downstream life and property, preventive measures were taken at the beginning of the construction. This included the construction of Gabian Check Dam and existing drainage ditches to intercept loose soil that might fall during construction. Additionally, sediment settling basins were set up at the outlets of the drainage ditches in the Baro area to prevent muddy water from flowing out and causing pollution. The excavation area for this project covered approximately 26 hectares. Since a total of 6.66 million cubic meters of earth had to be excavated and transported, an access road was first built to reach the mountaintop. Excavation was carried out in stages from the mountaintop downward, with temporary drainage directed to the Gabian Check dams in the drainage ditches to prevent soil and rock from being carried away by flash floods. The Wugu Construction Office, responsible for the construction, mobilized a large workforce and heavy machinery to carry out the excavation work in Baro Area No. 6, working day and night despite extreme heat. The excavation area had a terraced slope, with a height of 12 meters between each terrace. Platforms with a width of 5 meters were provided between the terraces, and platform gutters were installed on the inner side of the platforms to facilitate rainwater retention and diversion into the No. 1 and No. 2 interceptor ditches on both sides. The continuously excavated earth was transported away, and the newly excavated earth was used to construct a 1,500-meter-long, 19-meter-wide fill access road. The access road started at the feed hopper in Baro Area No. 6 and ended in the fill area, facilitating the installation of the conveyor belt system. The total volume of earthworks used for the construction access road is 65,000 cubic meters. This access road facilitated the installation of the conveyor belt system and served as a maintenance route for the conveyor belt, as well as for early earthwork operations before the conveyor belt was fully installed. It also served as the main access road for personnel entering and exiting the work area and could be used by trucks in the future to increase the transport capacity. Construction workers are currently installing the longest and most powerful giant conveyor belt system in the country, along the north side of the earthwork access road. This is a complex and highly technical undertaking. The giant conveyor belt system for transporting earthwork consists of a cluster of giant belt conveyors with a total length of 3.3 kilometers, all powered by electricity. It starts from the number 6 earthwork collection area, crosses the Wugu Changtai Road and the Wensichuan Bridge of the highway, and goes straight to the earth filling area. At the beginning of the construction unit had proposed 3 construction plans, using trucks to transport earthwork, using giant conveyor belts, or using sand dredging for landfill. After several discussions and deliberations, it was finally decided to use the giant conveyor belt system for the most economically efficient construction. The chute inlet hopper of the giant conveyor belt system is under construction, and it is located at the foot of the hill in the number 6 earthwork collection area, which is also the starting point of the giant conveyor belt system. The chute inlet hopper has a conical structure with a height of 17.5 meters and a maximum width of 30 meters. At the top, there are 4 feed chutes with steel rail-based grates at the bottom. When earthwork is poured, sand and gravel materials smaller than 20 centimeters fall through the gaps in the bar-shaped sieve and are conveyed away on the main conveyor belt below. Larger stone materials larger than 20 centimeters in size slide across the bar-shaped sieve, pass over the feed hopper, and then descend to a lower level where they encounter a coarse, heavy-duty chain-link grate, after which they slide into another intermediate storage hopper. Below the storage hopper, there is a stone crusher that crushes the larger stones into pieces smaller than 20 centimeters, which are then conveyed to the filling area by the conveyor belt. Workers are installing sets of rollers on the elevated structure. This giant conveyor belt system is supported by a steel frame structure and weighs 1,207 tons. The conveyor belts are then installed on the rollers, forming a cluster of giant belt conveyors. The main conveyor belt is divided into 4 sections to accommodate 4 turns in the terrain. Each section functions as a complete conveyor system on its own. M1 is 360 meters long and has branch conveyor belts TC1 and TC2 at its starting point, serving as a joint loading facility for truck unloading and crushing stone materials. M2 is 151 meters long and has 2 transfer stations at both ends to connect with different directions, and it spans over Changtai Road and the Wugu Interchange Access Road. M3 starts from the western end of the Wugu Interchange Access Road and runs along the road before reaching the M4 transfer station, which is 816 meters long. M4 changes direction from the transfer station, adopting a ground-level route, crosses under the highway bridge, and arrives at transfer station LC1, spanning a length of 201 meters. The giant conveyor belt system in the Wugu Industrial Park is the most significant earthwork transportation tool for the Taipei County Wugu Industrial Park project, and it was officially inaugurated on September 25, 1984. The construction unit used a fleet of 35-ton loading trucks to transport and dump earth and rock materials into the chute inlet hopper. When the start button was pressed, the guests applauded warmly, expressing their satisfaction with the introduction of this technology and equipment that reduces pollution and enables the efficient transportation of earth and rock materials. The giant conveyor belt system then began operation, bearing the heavy responsibility of transporting earth and rock materials. Earth and rock materials from the chute inlet hopper were transported along the giant main conveyor belt system from the number 6 earthwork collection area to the designated filling area, facilitating the filling operation. The conveyor system had a conveying speed of 240 meters per minute, with an average hourly transportation capacity of 2,500 metric tons of earth, approximately 1,800 cubic meters, and a maximum hourly transportation capacity of up to 3,000 metric tons. It was the longest and most modern earthwork transportation equipment in the country at that time, and when looking from the number 6 earthwork collection area, the entire conveyor belt system meandered through the green marshy area, resembling a giant dragon. Earth and rock materials continuously fell from the end of the conveyor belt system, allowing the earth materials brought from the collection area to be evenly filled as needed. With the close coordination between the conveyor belt and the dumping vehicles, a piece of reclaimed yellow clay soil from the marshland is getting larger and larger. Before filling, the construction unit specially installed layered settlement gauge, settlement plates, and groundwater level monitoring instruments at the site, and continuously recorded and monitored them. The data was analyzed by CECI using computers to control the quantity of earthwork and provide a basis for public facility construction. In the number 6 earthwork collection area, earth collection work continued. The excavation work proceeded from higher to lower levels, as there was a height difference of over 130 meters in the excavation area. The excavation and earth transportation had to be carried out in stages, with each stage covering a 24-meter elevation to ensure construction safety. There were over 20 bulldozers working in the number 6 earthwork collection area, and a large number of personnel and machinery were scattered across the vast collection area, creating a spectacular scene. The work morale was high. During the peak construction period, over 500 RSEA engineers and more than 100 trucks were involved in the operation, working in shifts 24 hours a day. At its peak, the daily earth transportation capacity exceeded 50,000 cubic meters, and the maximum monthly earth transportation capacity reached 800,000 cubic meters, making it the largest earth transportation volume in any project to date. Dump trucks continued to shuttle back and forth on the earthwork access road, unloading earth and rock materials into the chute inlet hopper. A control room was equipped with a computer operating system that could automatically record the hourly transportation volume and provide advance warnings or automatic emergency shutdown in case of machine malfunctions. Once the power was activated, the entire conveyor process operated quietly, minimizing noise and dust pollution. At the end of the conveyor belt is a self-propelled paver machine that is 151 meters long and equipped with 8 sets of continuous tracks for mobility. It can make semicircular movements, allowing the earth materials brought from the collection area to be evenly filled as needed. The Taipei County government, in order to provide land for the relocation of factories and residences within the designated area of the Akhong floodway in a timely manner, first completed the filling of 53 hectares of land as the first phase. In this area, various public facilities were built early, and an additional 1-meter layer of precompacted soil was added to accelerate settlement. The volume of precompacted soil amounted to 540,000 cubic meters, and the total fill volume in this area was 2.6 million cubic meters. The second filling area covers 82 hectares, with a fill volume of 4.06 million cubic meters. The original geological conditions in the industrial park were extremely soft, resembling a swamp with little usability. To address the underwater sludge, a portion of it was excavated by excavators and transported away by trucks. Another portion was solidified using sludge treatment agents, and the rest was mixed with mountain rocks and materials, dried, and then used for backfilling. Due to the introduction of a giant conveyor belt system from overseas by the RSEA and the use of dump trucks to transport soil, the land leveling and filling operations in the Wugu Industrial Park have proceeded smoothly. This achievement is the result of the hard work and dedication of all the RSEA engineers employed at the Wugu construction office. The even distribution of soil filling has accelerated the leveling and compaction effects of bulldozers and road graders, while also providing advantages such as time and labor savings, effectively controlling the quality of the project. To expedite the settlement of the soil, a 1-meter-high layer of soil was pre-compressed on top until it stabilized, after which any excess pre-compressed soil and rocks were removed. Looking down from higher ground, the original swampy area had transformed into a wide and flat new terrain. To prevent erosion on the slopes during construction, immediate vegetation cover was applied after each terrace phase was excavated. The beautification of the hillside vegetation was carried out progressively from high to low levels. The entire 1,600-meter length of the conveyor belt system was covered to prevent dust emissions. Throughout the development project in the Wugu Industrial Park, the owner, designers, construction units, and supervisory units all invested significant capital, manpower, and effort in pollution and noise control. By the end of 1985, extensive earth-filling operations had been completed, and the entire industrial park was showing signs of stability. The remaining settlement was also within an acceptable range. At this point, the construction of various public facilities within the industrial park began. The Wugu Industrial Park had a comprehensive planning and strict quality control, with related public facilities including sewage pipelines, water supply pipelines, drainage systems, road construction, street lighting, parks, sewage treatment plants, elementary schools, and service centers. Underneath the important roads within the industrial park, drainage box culverts have been installed. For this culvert project, a combination of precast and on-site installation methods was utilized to align with the construction of various public facilities. Precast screw-lock joints were used at the connections between two precast box culverts, which not only facilitated construction but also helped save time in the process. The industrial park had excellent street lighting equipment. The success of earthwork projects depended on the quality control, appropriate testing methods, the reliability of test results, and the expertise of testing personnel. Therefore, the construction unit, the RSEA engineering agency, and the supervisory unit, the China Engineering Consultants Incorporated, all put forth their utmost efforts. A total of 2,171 earth density tests were conducted in the industrial park. After passing the soil density test, the graded aggregate material is immediately laid. In the industrial park, there are roads of various widths, 7.6 meters wide for a total of 3,000 meters, 8 meters wide for a total of 8,000 meters, 12 meters wide for a total of 2,200 meters, and 19 meters wide for a total of 2,150 meters. The total length of the roads is 15.5 kilometers, providing access to every small block within the industrial area. The roads in this industrial area have a graded aggregate material thickness of 37 centimeters and an asphalt concrete road surface thickness of 5 centimeters. Their smoothness and construction quality meet the standards for general high-quality highways. Sidewalks are installed on both sides of the roads, and flowers are planted every 10 meters to beautify the environment. The Wugu Industrial Park, now known as the new Taipei Industrial Park, was originally planned and constructed with various facilities and features. The construction plan included the relocation of factories from the land designated for the Ekhong floodway, a sewage treatment plant, an industrial area, a substation, public utility areas, telecommunication facilities, standard factory space, residential zones, schools, service centers, community centers, markets, and gas facilities. The total investment in the Wugu Industrial Park amounted to 3.9 billion new Taiwan dollars. The Wugu Industrial Park is located adjacent to the National Freeway 1 and is in close proximity to the Taipei metropolitan area. With improvements in the surrounding road infrastructure, transportation to and from the industrial park is very convenient. The development of the land created a significant buzz even before it was put up for sale. It quickly sold out, with a total land area of over 90 hectares. The construction team, much like modern-day heroes, used conveyor belts and vehicles to transport and reshape the hilly terrain into a thriving community. They transformed previously unused swampland into an industrial park with optimal land utilization. Due to the rigorous construction process, the industrial park was developed to perfection, making it easy for factories to establish themselves. This, in turn, contributed to the flourishing economic development of the country.